Sorry, I was having some connection issues here, but we're gonna get started.
Okay.
Let me hold on a second. Pause record Zoom. Hi everyone. I just wanted to welcome everyone to the chapter 56 of the Institute of Industrial Engineers, Institute of Systems in Engineering here in Wichita, and welcome you guys to our webinar for July. Wanted to introduce our speaker, which I think everybody already knows, but just in case for anybody who might pick up the webinar and might not know who he is, we'll get the information in here. Dr. Huffman, he's currently the Senior Technical Fellow at for Operations Technology and Data Sciences at Spirit Aerosystems. He's also a fellow at Institute of Industrial and Systems Engineers. And he's also an educator at of Industrial Systems and Manufacturing Engineering at Wichita State University. And it's also emeritus president of the Greater Wichita chapter of IISC. So we wanted to kind of also mention some little known facts about him. Just learned a new one today, but he loves baseball and and golf.
Yeah, a little bit. Depends on the day.
Yes, depends. And also he just confessed to us that he knows he can name all the 50 United States. So
No, the presidents of the United States.
Oh, the president. Sorry.
Yeah, I'm really bad at geography, but I can do the presidents.
Oh,
I'll tell you what. If we get over early enough here, I'll do them for you. Okay.
All right.
I actually have trouble with the later ones because after when you learn them, you memorize them and you get that down. Then when you get new one, now suddenly you got to another one. Now you got another one. Now you got another one. So sometimes I kind of mess up toward the end, but
yeah.
I'll do that later on if we got time. But
all righty.
But thank you, Heidi. Appreciate it, and thanks, Heidi, for setting this up. We came into July. We thought we were going to have an event mid-July, and it kind of fell through. But we're working on other ones, obviously, and maybe even that one we'll do yet. And Heidi, if we got enough time at the end, maybe you could talk about some of the other stuff we got coming up. All right. Heidi's our event director. I think you all know that, and it's a big job. We're trying to help her out as much as we can, but it's her ball game, and even though we have, obviously, you guys all know we have some things we have to do every year, and we kind of have gotten into a cadence on some of those things. We still want to be flexible enough that we can have new things and more innovative things as we go along, and Heidi's going to lead us down that path. So thank you, Heidi, very much for setting this all up, and we'll get into it. I know I have to share to get my presentation up here. So host disabled, the participants screening share.
Oh, sorry about this.
That's okay.
Okay, I think you should have it now.
Okay, good. Yeah, I can see it now. Okay. So, are you seeing my screen now?
Yeah.
Okay,
yes.
Good. Okay, let me go to full screen here so we get the. Okay, good. All right. So, well, thanks again, and I got to tell you right off the bat, okay, you're going to see a lot of slides that I think some of you have seen before, okay, but I'm going to try to do this from a little bit of a different direction than I did in previous ones. In previous ones, I really talked a lot about the technology and especially the challenges that we have in doing digital transformation in business. By the way, not just business, but it's coming across almost all of industry, almost all of the world too, that there's a real focus on how we're going to transform our legacy, mainly by hand processes and something that's a little bit more automated and digital in nature. And of course, so everybody's here right now trying to make this happen. And yet there hasn't been a whole lot, in my opinion, of what I would call disciplinary direction on this. It's been kind of be we're kind of making it up as we go. Um, so much of it is obviously something that's in our legacy environment too. It's not like we just started doing digital. We've been doing digital since the 60s, right? And really since the 80s, it's been done on a wide scale basis. Most of the things that we're actually doing now and talking about now for industrial systems engineers, we pretty much have been doing these things for a long, long time. So one thing I will talk about a little bit in this is why now, okay? And I also want to do it from the perspective of what is there to gain out of doing this? All right. This is one of the things that I think a lot of companies are struggling with right now is they feel like they have to do this, but they sometimes feel like they're doing it just because everybody else is doing it. Is there real benefit out of doing this other than the stuff that we typically show in ROI reports? Okay, what other real benefit is there for going for digitalizing? And by the way, that is the proper term. I know a lot of people say digitizing. It's actually digitalizing. Digitalization is what the the outcome really is. We're trying to move from things that are fairly human centric and paper based to something that is really ones and zeros that are basically stored in databases and then are marshaled across our system to allow us to perform tasks, produce products, deliver services. So what kind of was the impetus for this? I have a very good friend. We went to college together, and he came to Wichita about a month ago, and we got to go out for supper. And he is the director of digital. I'm sorry, of manufacturing engineering at GKN. It's one of Spirit's biggest competitors, right? And so we always have to watch what we say each other about business, but we tend to talk more academically about things. And of course, GKN, like Spirit, is undergoing a major digital transformation effort right now. Um, and of course, when I talk about it and how what I think we're doing a little bit different than everybody else, I tend to focus on the systems engineering aspects of it. And he absolutely agreed. He said, it's interesting, John. We're running it as a lean project. I had never really considered that. Is this really a lean project to do digital transformation? So I immediately that night when I got home after we had a really nice night out together, I Googled lean digital transformation. They were not the only one who thought of that. And so I stepped back and I said, you know what? We are really doing a lean project here, okay? But it's not like your typical lean project in that it's not necessarily about techniques. It's more about strategy, about the lean strategy. So I decided to take some of the things I've had before and rework them a bit to be more of, what are we doing in the situation of trying to build this lean enterprise that we want to do based on really good digital practices. And it was interesting because as I went through it, almost everything I had ever put together before fell in place. And it actually made a really good story to this. So I thought this is something I need to vet a little bit with some of my colleagues. You know, is this the way we really should be thinking about this? Reason I bring that up again, we are trying to put business cases together. We are relying on vendors right now to help us with those business cases. The numbers they are coming up with are very suspect to me. I don't know where they're getting some of these massive numbers for savings from. All right. From what I've seen so far, there haven't been that many companies that have actually implemented this to a level where they can even claim those kind of or realize those kind of savings. All right. And most of them, short of almost eliminating the practice altogether, I don't know how you could even get a savings in it. Okay. Most of what I have seen so far has been let's replace things we've already got with something that's a little bit slicker. You know, I don't know how that improves quality in the end or anything like that, But when I do it from the case of lean, I could say, well, this is what it's doing. It's opening up the door for innovations and things like that that were always very difficult for me to do in the past. So anyway, I'm getting a little ahead of myself, but in saying this, okay, where I'm going to go with this is I'm first going to talk about enterprise. Okay, I've done this before with you, so I'm going to do it really quick. But it really does start with what I call enterprise thinking, those systems things that we have to do for the enterprise, and then the digital fabric. What are we actually putting in place to make this all happen? Then the ecosystem that we gain out of it, especially the twinning aspects, the idea that this physical system is going to end up being somehow virtualized for us, okay? And the products that it produces, we will also virtualize. So we got twinning from two different perspectives going on here, and I'll talk about that in a little bit more detail. Then something I think is absolutely key to this, and that is disruption and change. I won't talk a lot about these because I think it's pretty obvious. And we as industrial systems engineers, we basically live this. This is what we are about. Okay, we're change agents in our in our companies and our enterprises and whatever we're dealing with. Okay, but we're also the innovators. We're also innovators in our company, and innovation causes disruption. And even though disruption is most time looked at as being a very negative thing, in this case, could be a very positive thing. It's something we want to do. All right. We may actually be the ones who cause the disruption. And then part 5 on this is I'm going to talk about the analytic driven business. You keep hearing about data driven business. I don't think data drives us as much as what we learn from data. So I want to talk about analytics and how they play into the whole thing. And then finally, I'm going to wrap up with what I call the digital transformation agents. Who are those people and the skills and approaches that we need to use in order to have a truly good digital transformation initiative in our enterprises. So we'll start out with enterprise thinking. And by the way, as I go along here, every now and then I'm going to ask somebody to just say something, just so I know I'm not talking to myself. All right. So Heidi, are we still good?
Yes, we're still here.
Good. Okay, good. It would not be the first time I spoke for an hour and then realized that there was a technical hiccup and I had been talking to myself the whole time. So I'll just do that every now and then, ask you guys to chime in and let me know. All right. So,
no problem.
You've seen this. I've got a set of charts that I started building back in the early 90s that I have used and reused and reused and reused that basically talk about the history of us, the history of industrial information systems and the different epochs that we've gone through, the industrial revolution, the technological evolution phase, things like when we went into space, or we fought World War II and that drove technology, or sometimes technology drove us. It helped us create the internet, and I should say the internet technologies helped us build the e-commerce and blah blah blah. And then there's always been this pendulum that swung back and forth, which pretty much now doesn't even swing. I mean, they're both working together in unison, and we'll likely keep doing that. And I really think it's got a lot to do with this thing that we call this digital imperative. That started way back when, we first started creating programming languages and the rudimentary databases that came along, and then that finally morphed into relational models, relational modeling, relational databases. Object orientation came along, and then the wide scale distribution of information and the ability to globally connect through the internet and all that. That's all been this digital imperative that's led us up to this point now, where we need to say, okay, those enterprises that evolved from human practices now have to let go of some of those physical things and make things a little bit more virtualized, and more integrated with each other and more flexible. In fact, what I would say is trying to become more agile. I think that's kind of the nirvana of this, is that when we are able to, regardless of who creates the systems, regardless of what kind of format the data is in or all that, our companies could readily adapt its ecosystem for doing this quickly and can actually utilize different methods depending on what you're doing. One of the struggles we have at Spirit, is the fact that we work with for a lot of OEMs, Boeing and Airbus, and we also have a lot of suppliers. We also have commercial work. We also have military work, space work, defense and space. We do things for the government sometimes that are really black ops projects. Um, what do we do? How can we have one ecosystem that handles all that stuff when we have information that's coming in at different points in different formats and we have to send things out to the world? you know uh, there may be a time in the future where we engineer airplanes on our own. What do we do when suddenly we're not getting engineering from Boeing or from Airbus? What happens if the day ever came that Spirit decided to do a whole different kind of aero system other than an airplane, and now we have to have a whole different set of people that we interface to? The fact is we don't have a lot of standards in our industry, so everything is kind of fair game right now, and it's causing a lot of upheaval on these projects, for these digital transformation projects, to figure out what truly is the best approach. At Spirit, we call our thing Spirit One. A lot of people think that means we're going to have one set of systems that will do this all. The truth is, it's about building one infrastructure that could support it all. And when I say infrastructure, I mean both the technical infrastructure of a network, the cybersecurity that goes into it, the data lake that's behind it, and then anything else that's used to create a workflow through the thing. So we got all this stuff going on right now. Where did it come from? Well, I think it really started with big data. The fact is that we realize, hey, data is really the new um, fuel for our enterprises. Okay. And the ones who utilize their data the best, they're the ones that are going to be the most competitive in the future. Yeah, there's some truth to that. Okay. uh, Kind of went overboard in some areas. We tend to do this, we get a little hype in this, but it's come down to earth here in the last few years. And from that, those things like digital transformation have come out, especially anything that wraps around the analytics part that came along with it too. The other thing, and this is why I really like this subject a lot. I think artificial intelligence has had a lot to do with the mindset that we could have a um, a transform our environment into something that is truly digital. The idea that a lot of the decision making that we have done in the past, and a lot of the scientific discovery that human beings had to do, can now be fairly automated, or at least assisted with digital methods. I think is very appealing to our businesses now. And of course, they see things like Google making their, Google and Amazon and Apple all making their home appliances and smart home stuff, and Siri and things I could talk to, and it talks back to me. I mean, I'll tell you, natural language processing used to be the hardest thing in artificial intelligence. It used to also be the thing that we did the least. Now it's the thing you see the most of. In fact, Tate and I have had this conversation. I keep telling everybody that what was old is going to be new again. Okay. We basically went and did the thing that we couldn't do before. And now we're revisiting all those other things that we actually did pretty well, and we kind of got away from, or people just didn't understand enough to know that they were worthwhile. Now they're going back and looking at the deep learning, what we do with neural nets, what we do, knowledge-based systems. KK, you and I've had this discussion. It's coming back. Okay. I go out there and see the stuff the Europeans do, and you see knowledge-based systems all over the place. Okay. It'll just be a matter of time before that trickles into the United States again. So another thing I think is really helping now, that tends to be the technical parts of this. The other thing I think is really helping this game right now is something I call the domesticated technocracy. The idea that enterprises aren't just in big sites anymore. They could be in your basement. You could be right now. I mean, some days when I'm working at home, Spirit is in my basement. Basically, that's part of the Spirit enterprise, is my basement. The ability of technology to actually help us do our work. Okay. And I mean, work on a big scale is a major uh, development here that's happened in the last 10 years. And the word technocracy, if you look it up, means technical leadership on a small scale. I think that's the thing that is most important in this whole slide, is that we can now do massive things with a few resources. You know, some people who really are technically adept could get together, or even, and I say get together, they could be a world apart, but yet the technology allows them to get together and allows them to lead things. It's amazing what we could do now. And think about how many Zoom meetings we have in IISC, where before we had to get together. Now we could do things over Zoom and actually run an entire chapter and do a pretty good job at it. So anyway, those kind of things are having collaborative markets, obviously. Okay. Does anything happen in China that doesn't impact the United States and vice versa? It used to be, there was a time when, I'm a little bit into the stock market. You would see what the U.S. stock market did, and then you would pretty much predict what was going to happen on the Nikkei and all that later on. Whatever we did, they kind of follow suit. It's not that way anymore. Not a lot of times we'll have a down day, and boy, they have up days, and guess what? Then we have an update. It might be that we're being influenced by them now. Who knows? I think it's a two-way street, personally. And then, of course, lean and resiliency. Okay. Even though I call this a lean digital transformation that we're doing right now, the other thing is it's highly resilient. Okay. Again, we are going to have disruption and we'll be able to recover from it. And then, of course, enterprise management, the whole idea that we are not just focusing on those assets that we consider content, but any asset of the company. So I put a little post-it note on here, and it's been on here for a while, and it's still true. We are in a period where innovation is starting to outpace industry's ability to adopt it. And I think that has been magnified here in the last year because of COVID. We're not seeing as many people going back to work as they were. We know that there's a grain of the workforce, and there's a real concern about having, backfilling those positions, having really good succession planning. And of course, the other thing, and this really impacts almost all of us, okay? I mean, we are all engineers, we are all STEM workers, okay? We're not producing as many. At least we're not producing as many to keep up with the statement of work that's out there right now. So there's already talk about the government subsidizing anybody who wants to go for a STEM degree or an advanced STEM degree. They know they need that talent, and it's just not out there. But one thing I wanted to point out is that up till now, again, the focus has really been on those things that when we call it an asset, would be those things that tend to be tangible. Okay, things that are material, things that produce energy. Okay, we haven't really thought about our data as much as being an asset as it is. Okay, those of you who've had my information systems class have heard me say that this many times. If data suddenly became a physical thing, we wouldn't see the other stuff because that's how much of it there is. And yet for years, data was pretty much an artisan practice. Yeah, I know we industrial engineers use it for our OR problems, for doing analyses and all that. And that's why we are so important in this equation, by the way. Okay. But the rest of the world wasn't, you know, the best they did is maybe sum up some numbers or take averages in a spreadsheet or something like that. We didn't have a lot of people who really understood the value of data and how it becomes information. So the problem with that was a lot of it's junk. Okay, a lot of it is what I call digital waste. It's taking up space in our databases. It's overwhelming the processing that we do. you know Lean thought would be eliminate waste. And I think that of all the things lean can help us with in doing digital transformation, it can help us find those points in the process where data isn't right. Either we're producing too much of it, we're keeping too much of it, we're not getting the right stuff. We could consolidate it, we could represent it a different way, we might collect it in a different manner. There's a whole big bunch of stuff that I think the lean guys could do for this. And I think it becomes very apparent when you even think about the enterprise as a system. Think of all the things that are interplaying with each other in our enterprise to either produce a product or deliver a service. Okay. It isn't a thread. everybody talks about a thread of production. It isn't a thread at all. It is a fabric of stuff. There are threads all over the place that need to be woven together to make this work. Okay. Now, yeah, we could talk about this from the perspective of a thread being the traceability of a product or a service as it's being processed. But the truth is, to me, the fabric is the system itself. Okay. It's the system that that we're building. And hopefully it is woven tight enough that things don't fall through it too easily. Okay. Um, and I'm going to come back to the whole enterprise concept later on in this, because there's a little bit more to say about that. But I do want to segue right away into this whole idea of a digital fabric. Okay. There are things out there in the world that are being developed that are supposed to help give us some guidance to this. Okay. Um, as I said, there are a lot of companies are involved in doing this. There isn't a lot of standardization. There isn't even standardization about the approach to do this yet. All right. So ISA took it upon themselves to look at what I would call the manufacturing operations management portion of of a production thread. Okay. Now, for those of you from the service industries, you'll be able to draw a lot of analogy to the manufacturing examples I give, but almost everything you hear me talk about, because this is what I'm working on, will be manufacturing oriented, but I'll try my best to talk about them in very general terms. So ISA 95 came about I think it came about out of Europe. All right. And their idea was, we know that with IoT, the industrial Internet of Things, with Industry 4.0, we're going to have all these edge technologies that are going to be there for automation purposes, and those machines will have to talk to each other. The businesses that had those machines will have to talk to each other and all that. But the truth is, we are measuring things directly from the product. How do we get to that point where we know the things that are driving our equipment, that the things that we're measuring are getting fed back in a way that will help us improve our practices and things like that. Okay. So they came up with this level approach, with level 0 being the actual physical production process, level 1 being the methods of sensing in that process, level 2 being the ways of monitoring that process, level 3 being the workflow, and level 4 being the way we actually plan that workflow, or the logistics of the workflow. Okay. So, when you think about this from life cycle, it really goes the other direction. It goes 4, 3, 2, 1, 0. I mean, the product's going out the door, right? Okay. But from a technical build approach, you want to start at the end and work your way back, because it's an end-to-end situation in that case. Or I'm saying end-to-one situation. Okay. So you could track all those paths and rationalize about what you need at each one of these levels. Okay. When we talk about digital transformation and building an ecosystem for production, there's really a fifth level here. Okay. And that fifth level is, you design the thing, right? So you'll hear a lot people talk about the product lifecycle management that's done here. And the sad thing about this is, it depends what they're talking about, what that phrase means. By the way, this has been one of the hardest parts about doing all this stuff, is the fact that sometimes the same term can mean different things depending on the context you're using with. All right. Gartner actually realized this, and they put together this slide, which I love, which kind of straightens it out, that PLM, the way we thought about product lifecycle management up to now, really has been about an application. It's the stuff here that's in blue. Okay. About designing your product, generating a bill of material, parts list, and all that, basically putting a release package together for your product or for your service. In our case, we use CATIA a lot. It could be NX if you're any kind of CAD CAM system. It could be some kind of computer-aided service system that you're using if you're in the service industry. But that is a very limited part of the life cycle. That's really the stuff that happens up front by design engineers, if you will. All right. You'll also hear PLM being used in terms of the entire ecosystem. All right. Those things that not only include this application, but then also include planning and production, those kind of things. And then there's PLM, the discipline, how you actually govern that. All right. I'm going to talk to all three of these, but from different, from perspectives of things you probably have heard of, and definitely things that I have talked about, which I think relates to this. Okay. The PLM ecosystem is what Dassault and Siemens and those guys are all trying to market to you. Okay. It basically starts with requirements, goes through engineering design, into manufacturing planning, and then finally delivery of that plan to the work, to the shop floor, or to the mechanic, or to the automated device, or whatever else. Okay. But generative artifacts basically that end up in our factory and help produce the part. Okay. Now, some of them have taken it another step and actually gotten into more of the IS 95 and said, well, then it also includes the segment of material management, inventory control, other supply chain stuff, driving equipment, measuring how we're doing that, and even transporting it out, and maybe even servicing it on the back end. All right. Truthfully, I would love if the ecosystem included all that. I have yet to find a vendor that really has all that. All right. More in common, what you'll see is a PLM ecosystem by one of the major vendors. And then you have to go out and buy a platform for IoT and get them to work together. All right. And then PLM we'll talk about in terms of what I call enterprise architecture in a second. But if we really wanted to talk about the big picture, this is the big picture. These are all the things that are involved in what I believe is the ecosystem that we're driving to in digital transformation. We take demand from our customers, we manage the product through its design and anything else. Uh, we design based on manufacturing specifications. So this is your design for manufacturability that you sometimes hear about, that will consider what manufacturing needs to be done as we produce that design. And then we actually manage production. So this is where our facilities, our machines, all that. And actually between this is the planning of all that. All right. Until finally we do it. Now we have to control those processes that are being used to create our product or deliver our service. And somewhere between that, we have to basically govern that, and all the data that is produced with it. Okay. Most of the time when you talk about digital transformation, the onus is on this part and this part. And in fact, I'm going to show that right now. The PLM ecosystem. So those of you who are from Spirit, this is really what Spirit One is right now. Then there's the rest of ISA 95, which John Huffman is always concerned about, and asking, where's this when we talk about Spirit One? But then there's also this part here where we talk about production system management. And that's what we could do through enterprise architecture. And that's where I think especially ISCs have a major role in all this, making this happen. So this is a very involved chart. I am not going to step through it all. All right. But what it tells you is this. Okay. We have a value stream, a production value stream, that right now we are mainly addressing the product lifecycle management portion of it, which is engineering design, the business process, the business planning and logistics, which is the manufacturing planning that we do, and then the things that actually happen down in the factory, the manufacturing operations management and the manufacturing control that happen. This is what most of the vendors out there, their product base talks to this. Okay. Plus, they usually integrate with a enterprise resource planning function. Now, I put that over supply chain. Truthfully, it's throughout the whole process, okay? But it's mainly there. In the future, it will be mainly there for the purposes of what we do in supply chain. The fact that we need to manage inventory, the way that we need to marshal information in and out of our business and all that. That will be all mainly something that we do in supply chain. At Spirit, we do it used through SAP. Truthfully, at Spirit right now through SAP, we're also doing a lot of the business planning and logistics. The idea is in the future, this will be its own thing, basically. All right. Now you can see here, I put the boundary that right now ISA talks about all this stuff, but has kind of ignored this. And that's why I believe there's a level 5 in there. Beyond all this, we also have the situation that once the product goes out the door, we don't forget about it. So we have this idea of doing customer relation management, having smart MRO. Many of those vendors have talked about the fact that they've been able to integrate with customer relation management and performance management systems or platforms in order to make that happen, to give a complete life cycle. Again, they tell me that. I've yet to see a business, any use case where that's happened. Now, I will tell you, Accenture has told me, and Accenture doesn't offer a product suite, but Accenture has worked with most of them, and they have helped integrate different platforms together to build something very similar to this. Okay, I just started working with them recently. I'm really curious as to just how much depth they've given on all this. But one of the key things you're going to see on this chart is this whole idea of model based. Okay, that is our rallying cry, because right now our data is in a lot of different formats: files, objects, you name it. Sometimes it's not even textual data. Sometimes it's in audio or video. Okay. The fact is, in the future, what we want to be is more object oriented, and that screams model based. So we'll have model based engineering, which is basically the geometry, the 3D geometry, the bill of material, the parts list, even some of the work breakdown structure that would be reflected in the master schedule for what we want to do in production. That's all part of the model based engineering that we're putting together. From that, we derive model based manufacturing. The plan, basically, the manufacturing plan is the big manufacturing model, but that also includes logistics. It includes process. Hey, if you're not thinking discrete event simulation here, you're missing something. Okay. And oh, by the way, I should say that back here too. This also includes what I would call physical simulations, things that we do for aerodynamics, finite element analysis could be used here and all that. That's all part of that model-based engineering. From that, those fuse together, add some stuff about automation, you get model-based production. And overall, you end up with a model-based enterprise. And if you've done a really good job of sharing knowledge through the whole thing, first off, understanding knowledge that you create, capturing that knowledge, preserving that knowledge, distributing that knowledge, utilizing that knowledge, and actually knowing what that knowledge did for you, and then keeping it current, then you've really created an intelligent model-based enterprise, which I think is what this overall thing is. All right. Now, everything down here is our physical environment happening. Yeah, we're using systems to do this digital transformation of information of models as we go along. All right. And by the way, in fact, at the end of it, we end up with systems of records, things like the as-built record of the airplane, if it's an aircraft, if you're in the aircraft industry, things that will allow you to traceably say, for this instance of this product, this is how we did it. This is where we did it. This is when we did it. This is who did it. This is the things we learned in doing it. Okay. It is a full traceability and authoritative record of how we built the airplane digitally. All right. That's what really the major deliverable or the major artifact is that comes out of this. But along the way, we might actually have like an as engineered record, and as manufactured, as produced, as supported, whatever else. Okay. To do that and do it well, I mean, shoot, do we just go do it? No, we try to figure that out virtually before we do it. So there's a virtualization of all this that we call the twins. Okay. And there's two types of twins. There's a product modeling and tools twin, and then there's a factory modeling and tools twin. Now, I've got these kind of going from product lifecycle management and manufacturing operations management. The truth is, there are many things that could types of simulation that could hook into this, and other analytics that could hook into this. Okay. But the idea is that they should work together. We can't divorce our product from our process, basically. And they need to work together, and we need to have an overall organized, wide scale, massive simulation method in order to make this happen. All right. You want to know what our Apollo program is? This is what it is. Okay. ISCs especially will be responsible for creating enterprise-wide models that are agile and flexible, so that as changes are necessitated in the physical process, we make it happen virtually first, so we know what we're getting into. Okay. Key in this, I think, is the utilization and the development and utilization of knowledge. And there's different kinds of knowledge strategies that you would use as you go forward, both in the physical process and in the virtual process. Knowledge-based engineering are things that would allow us to have a feature-rich engineering design that we can then mine those features by using knowledge-based engineering for manufacturing to actually generate things like our work instructions, our NC program, our inspection plans. All that can be generative based off directly off of the information that comes across in the engineering in the model-based engineering method in that engineering release, if you will. And then in production, we'll have knowledge-based manufacturing, where not only are we utilizing mainly AI techniques to make production smarter and all that, but we're also allowing information to be structured in such a way and available to people who are designing, so they know that at any given time, what is the best way to design this thing I'm working on right now so that we can manufacture it. Obviously, the state of manufacturing is constantly changing. A lot of the things that we produce could be produced by multiple machines that we have. Which is the smart one to use at any given time? I may plan for it to be on the machine that's most cost effective to start out with, but along the way, schedule could start getting to be a situation. And now maybe I'm going to use a more expensive machine because it's available and I could get the thing out on time. Those are the kind of things that need to play into this. That things that sound a little bit operations research oriented, don't they? So I think that's a big part of it. I'll come back to this in a second because there's some other things in here that I need to point out as I go through. The key to all this is the fact to recognize that this is not about software development. Yes, the application systems are critical to actually point to a digital production thread. In other words, a digital thread of processing that happened, okay? If you don't have your data in place and done it right, what good is it? You're just processing garbage, okay? And more importantly, if you don't know what you're going to do with your data, either data that you derive from this or data that's embedded in this thing with analytics that are embedded this thing to help you do guidance of the process, what good is it? All right. And to get that right, you have to have you have to have a really good business architecture. You know, tell me what, I'm just going to pose a question to all of you. What do you think right now from a business architectural perspective is the thing that's keeping us from doing this right now? I mean, don't get me wrong, we are doing it, but what's been the biggest roadblock to progress on this? Anybody want to take a shot at this? Is anybody there still? Let me ask that. Heidi, are you still there?
I'm still here.
We're all still here.
I was gonna say just doing things the way that we always do it.
Yeah, that's it. Culturally, we refuse to change. Okay. And it's because we haven't done a very good job of educating people on why we're doing this. Okay. You would not believe how many meetings I still have where people are getting online for the sole purpose of figuring out, what does this mean to me? They're looking for any little tidbit that we could say about what they do and how it could possibly change because of this. Okay. In fact, it's interesting because everybody fears it. No one even thinks that we're trying to do something to make their lives better. Okay. Chris, you're on. Do you agree with me? I'm asking Chris because he lives this basically.
Yeah, there's a lot of folks who have their little silo and they're like,
right.
This is what I know. And depending on your age, you may not want to learn something new.
It's that old Machiavellian quote, when you try to be a change agent, you're going to have as detractors anybody who ever did good under the old system, and you're only going to have lukewarm support from those who could possibly do good under the new system. This is that on steroids, okay? I mean, there are more people, I think, right now who want to fight this change than they want to be part of it, and that's a shame because I think everybody has a really big role and a lot of benefit could be gain from doing this, and especially us in industrial systems engineering. Um, not to and just really quick, okay, again, there is a lot of variability in this stuff up here in process data and application, where I think we need to strive for stability as an infrastructure. Both having that computing infrastructure and the security infrastructure in place and repeatable and stable is going to be critical to making this happen, because this is going to be variable for a long, long time. We will have some standardization within this as we go along, but I'll tell you right now, I'm on one right now where with the it's called the Business Technology Interoperability Committee that the Aerospace Institute of America, or Aerospace American, I always get it wrong. Aerospace Institute of Association, or something like that. I forget what I mean. It's a conglomeration of everybody who's involved in aerospace, including vendors. Okay, are getting together to try to actually come up with a standard for how we would do data and all this. Okay, I've been in it for a year and a half, close to. Okay, it's like watching an iceberg melt. Okay, of course, with global warming, it's happening a lot quicker these days, but maybe I should have said iceberg move. It just is horrendously slow, trying to get everybody to agree on everything. There has been some progress, though. I've got hope, but until we actually get to a point where we have standardization up here, we're going to have to really rely on the fact that this is ready for us. And that's why I keep saying at Spirit, we really need to focus on this and our data. In my opinion, we've jumped to square four, but what do I know? I'm not a vice president. So anyway, I see enterprise strategy over this. Okay. I don't mean I'm not saying anything negative about the bosses and all that, because they are the ones who are putting this in place. They are obviously concerned. This is a big expense. This is a big investment. Again, I think sometimes they even feel like, are we just doing this because everybody else is doing it? But at the same time, they also have seen some really good things in the last few years where we've been able to do things like this on a smaller scale, at least, and proving the point. So now the question is, what's the cost of scalability? How do we make this work in a more enterprise fashion rather than on a particular program or something like that? So the ecosystem, and this is critical, all right? Because even though there's a lot of vendors and a lot of those vendors are think they're competing against each other, the fact of the matter is I haven't found two yet that have the same tool set or have even approached it the same way. All right. You have some where they've taken the approach that we're going to give you a lot of stuff and then we're going to come in and configure that stuff for you to make it work in your environment. Okay. The other end of the spectrum is we have this, you have to change in order to utilize our thing because we believe what we have is best practice. Okay. And then you got some that will be in between them. Okay. They're trying to give you templates. They're trying to say there are some things we've learned that worked really, really well. And we think you ought to be doing it this way. At the same time, we understand that different industries are going to have different needs and will give the ability to customize. All right. Obviously, the more customization you have, the more effort it takes by whatever team is building this. Okay. And by the way, the team may not be your team. Okay. It could be a team that you've hired in to do it, a team of integrators, we would call it. It could be the vendor themselves, or it could be a combination. Okay. A lot of the vendors, in fact, look at this and they're not seeing this really as a software development project as much as they're giving you a service. They'll help you put the software in place. You'll definitely pay them for that. You'll definitely pay for the software too. But they're not walking out the door once that's done. They're staying and they're running the system. In fact, they may even want the data up in a cloud that they take care of, and they're going to analyze your data for you. Well, that sounds neat, and it usually is a way to eliminate some of the costs, and of course helps you with the fact that if you don't have the skills, you're basically getting the skills from somebody else. Okay. The problem with that is, are you giving away any of your competitive advantage doing that? By me letting somebody else have my data, is that a good thing? would the defense allow anything like that? Nope. So again, we've got different aspects of how this thing is being developed and marketed in industry that's causing incredible consternation and incredible confusion among those who are trying to utilize commercial off-the-shelf systems to do this. In fact, I'll go you one further. I think most companies can take what they've done already and upgrade it, just do a better job of integrating, and they probably would have a lot of this done already. Again, I really question the benefit of just swapping out one system for another, unless you could really point to some major improvement to the product or to your production life cycle. And I'm very dubious about that right now. But here are some of the key players. I've had the opportunity to work with 4 of them so far. And again, some of their stuff doesn't look that much different from each other. Other things are very different. In fact, it's kind of interesting that where they're very different tends to be in the middle, where things have been have been less conceived in the past. Okay. We've always had the ability to do CAD CAM up front. We've, for a long time, have had the ability to do manufacturing execution on the backside. What we've always struggled with was how do we connect engineering to manufacturing? And that's where, like I said, we have actually done that through things like SAP, and it's taken a while. So they're trying to get out of that and get us into a better environment where we have planning now. But it is those middle systems, those systems about manufacturing planning and scheduling that tend to be very different from one product to another. The other thing, and I should mention this right up front, and I'll get to say this a little bit more in a minute. They also have fundamental differences in how they work with and produce data. And that is something I'm very concerned about, because again, data tends to be in the background. Everybody just thinks it's going to work all the time, and yet if we don't have it in the right format, we could spend most of our time doing nothing but translating data to make it work with the system. And then that causes things to slow down and it reduces your ability to do real-time things at the edge. And that's all things that I think we need to think about, and we need to actually model it better. And the more we can do that virtually and do simulation on it, the more it will help us understand what our databases need to be like. So segues into this chart. This is one I found for PCLM, product lifecycle management, but the truth is it's the same kind of thing with almost every part of this, that there are basic functional components that we really should simulate in order to understand how we're actually transforming data from one location into data from another location. And then also having the side effect of producing knowledge with it too. And then how do we manage the knowledge? So again, digital twinning, and I mentioned this a few times already, so I'm not going to go into any more detail on it, is basically the virtualization of physical things, okay? Those physical things, again, in industry, we tend to think about it as the product. We also thinking about it as equipment, but we should also thinking about it as the process itself, It really, Chris, you've heard me say this before. It really is disheartening how the vendors present discrete event simulation in this whole thing. They almost have it in there as if it's an afterthought instead of being an integral part of how we understand and utilize the system. We talked about the fact that for years we've said that there are things we do in simulation that if we had the ability to replicate that in a more real-time manner, we could actually embed that and make our systems so much smarter. Okay. I believe we have the opportunity to do that here. I don't believe there's a product base out there that's open enough to allow us to do it. We're going to have to figure out a fancy way of producing what I call a knowledge layer to whatever we put together that will allow us to do things like that. So anyway, I'm sorry, I didn't mean to sidetrack there, but I'm going to go back to this because it kind of is my segue into another major aspect of this, and that is the enterprise intelligence, the stuff that we do in order to preserve our knowledge capital and make that available to everybody else. Okay. Knowing that, again, enterprise does not just mean company. All right. First off, in that vein, it means our suppliers, our OEMs, all those guys, anybody who is a player in what helps us be viable as a company or whatever we are, okay, as an entity in this industry, okay. We have to be concerned about that, all of that is the enterprise. But there's another definition of enterprise, and that means to be new, innovative, interesting, to enterprise, to go out and do something, okay? And I think that's just as big a thing in this enterprise intelligence. Both those definitions play into this. It's about us preparing for the future. How can we build the next generation of airplane based on what we know about building airplanes like it before? Now, we do things like that. When I first started, it was you go down to the data vault and you pull out Mylars of things that look like it, and you put a new Mylar on top of it, and you trace it, you trace it for a new airplane, That was innovation back then, okay? I think we're better at that now. Now we could say, you know what? We have learned a lot about building a single aisle airplane. What happens tomorrow if suddenly we decide to manufacture that vertically instead of horizontally? Whoa. Does a lot of that what we did before apply? Yeah, probably. Probably. Okay. Probably some of it doesn't. Okay. But we probably have done other things that are vertical that we could learn lessons from. Don't we build rockets vertical sometimes? Not Spirit, obviously, but other companies. There are probably things that we can learn from other industries that do vertical manufacturing. When I say vertical, I mean actually up and down. The thing is being assembled up and down rather than, left to right or whatever you're doing it. Okay. The other thing here is obviously, like I said, the situation that we have OEMs and suppliers, they themselves will have their own method of doing this. How do we map them up? This is something we struggle with a lot. What do we do when Boeing has decided they're going to use 3DX for everything they do, but the Air Force has told us they prefer we use Siemens? Oh boy, now we got a problem on our hands, right? So are we constantly translating data back and forth? Or is there a smart way to do this so that maybe at times we're doing it in Dassault and times we're doing it in Siemens, and it could change out throughout the life cycle? Maybe the Air Force is only concerned about how we do PLM, the PLM application, the engineering design part of this. And downstream, they don't care if we use Siemens, Well, that's great, but now we got to go from a mainly object environment into a mainly file-based environment. So yeah, now we got some data translation that needs to be done there. I know I'm doing more of describing the water here than giving you a solution. That's only because I'm still trying to figure out the solution to all this, okay? And so is like about 800 other people I'm working with right now. But the cool thing is we are starting to get a really good grasp on how to approach this, okay? One of the major activities that we have in here, you look at this and you see, conspicuously these arrows that are pointing left to right, like you usually see in the life cycle. There's also feedback. Okay, I can tell you right now, as a guy who's worked in IT for years, the costs going forward are staggering enough. The costs of doing feedback are tremendous. Okay, there are so many possibilities when you have to do design change or production change, and bringing that back to maybe even at the beginning of the life cycle so that engineering designers are actually doing good design work. It could actually come back to a lot of points in the life cycle. All right. How do we handle that? And that is yet another thing that I've seen so different between the different vendors who have products out there. And really, truthfully, different between the different aerospace companies that I've worked with, how we actually do change management. We only can agree on one thing. There needs to be a change management process, and the quicker we can standardize that, the better things will be. So, and that was the view of change management, basically from what's involved and who's involved in it and all that. This is more of a look at change management as it would be part of a continuous improvement cycle. So in doing change, what are the things I hope change will impact? You know, our adaptability, our reliability, our maintainability, our variability, you know, maybe reducing that, or in some case introducing it where it makes sense. And then the producibility of everything, and having that come back earlier in the life cycle, as early in the life cycle as we can. So to make a nominal system process, nominal models that we can utilize. And are you guys still there? Heidi's still there?
Yeah, we're still here.
Okay.
Here.
Okay. Well, let me pause right here. Okay. Because I've been talking for a while. Are there any burning questions about anything that I've talked about so far? Because I'm about to get into, I think, the rub of this whole thing. What does this really mean to us as ISCs? So let me go through this, and again, at the end, you'll get another opportunity to ask questions. And by the way, you can ask questions at any time. Feel free to jump in if you need to. Okay. So, you know, I've been using this phrase collaborative enterprise with the idea, because, you know, I think a lot of you know, my job is a big picture job. You know, I get involved in strategy a lot in the company, and it's gotten to a point now where I'm almost getting involved with strategy for the industry. You know, like I said, I'm on this BTIC thing with Craig Walters because he's the informational technology enterprise architect, and I'm considered to be one of the operational technology enterprise architects. So we're representing Spirit on industry consortiums where they're both looking at standardizing this thing, and then what technical research needs to be done in order to help out the industry. Okay, I've got something I've got going on with the robotics, Advanced Robotics Manufacturing Institute right now, to look at how do we actually incorporate AI not only into robotics, but utilizing AI to help robotics in our processes. Okay, and that is an industry endeavor. It's not just the Spirit thing that we've got going on right now. So, you know, I've noted that, again, we are all trying to do the same thing. We are trying our best to share with each other without divulging everything, obviously, you know, where we're allowed to do that. Okay. And the one thing I've really come to realize is that it is really about the merger of physical assets and digital assets. That you know, we spent years trying to separate the two of them, and now we're talking about bringing them together. This goes back to what I was saying before. If we can make living simulations that are part of the production process, in other words, maybe you come in the morning and overnight the simulation ran and it told you exactly what you need to do in your segment of the factory, you know, because it's examined all the state parameters, it's examined the production flow, it knows about the resources and their availability, you know, and even could build into it, well, what if so and so doesn't show up today, you know, then what are those paths, and at any given time, what is the critical path, and how susceptible is that to variations in what could be happening. Okay, so it's bringing people, things, and businesses, in my opinion, plural, together on this. Okay, you know, a lot of what drives Spirit in the factory is what our suppliers give us, and their ability to give us good quality products on time. You know, when it doesn't happen, it reflects not badly just on them, it reflects really badly on us, because Boeing, if they catch it, they don't care where we got it from. They just care that fact that we let it go through to them. You know, if it's a non-conformance or something along those lines. So you know, it is really about bringing all these things together and leveraging technology to make that happen. Okay, if you look there at the bottom, you see enterprise architecture, big data. Okay, that's how this all started out. Okay, let's make it about let's drive our companies from this massive amounts of data that we have. And oh, by the way, we need a governance process over it. We'll call that the enterprise architecture. Okay. Turns out enterprise architecture is a lot more than that. Okay. And again, I'll talk about that a little bit more in a little while. But that was out there 3 or 4 or 5 years. Lots of stuff happened. The big thing that happened out of it, data sciences emerged. You know what? We are not driven by data. We are driven by what we learn from data. Therefore, we need to have an enterprise analytics function in the company. Now, I'm not going to say every company has done this, okay? And most companies that do have an enterprise analytics function, it is not something that you see on an org chart, okay? In fact, it's something that tends to be distributed throughout the company, and sometimes those groups don't even work very well together, all right? But the companies that have done it right have recognized that enterprise analytics is a logical function that needs to be governed by an enterprise architecture team, okay? I have been trying really, really hard before I go out the door to make this happen at Spirit. Okay. It has happened to some degree. And of course, like everything else, the buzzword analytics, everybody loves that word and everybody wants to have an analytics function aligned with them. But that doesn't mean it's being coordinated very well. It's not being coordinated from what I would call a full ontology for analytics. And again, I will talk about that in just a second here. And then enterprise intelligence, okay? What we derive out of actually doing all those analyses. And there, I really think it's how data science allows itself to be utilized in real, not necessarily in real time, but in the process itself through what I phrase as machine learning. Okay. I know machine learning has more of an AI connotation with it, but there's also the idea of machine learning being the fact that machines themselves can garner understanding based off of their own performance. Okay. And yeah, you do need some AI to do that, but we can also do it through other techniques that we have. Clustering, by the way, tends to be one of the big ones. Anyway, let's start with big data. And I'm not going to talk through this whole thing, but when big data first started out, it was entirely something that IT was focused on. In fact, that's why enterprise analytics is typically thought of as being an IT function in the company, because it was about informational technology, building data warehouses, visualizing our data, maybe doing some visual intelligence things that we then would visualize and all that. Making dashboards obviously was a huge thing, okay? But there were interesting technical things going on that drove that, okay? One was we got a lot of data. How do we analyze a lot of data at any given time? Spreadsheets, bog down really quick, And so the question was, can we do some, first off, is there a way that we could split up analytics, do things and then bring it and then fuse it together at the end? And it didn't work that great. Okay. What about the data itself? Maybe the representation isn't correct. Maybe querying against relational databases isn't necessarily the most effective way of doing it. Well, that might be too. Can we treat data as objects themselves? You bet we can. We do it in geometry all the time. All right. What about in memory? What if our databases weren't something that ran off of a hard drive, but were actually always in the memory of the computer? Whoa, now there's an idea. Things would be a lot faster. What if instead of having things record by record, we do it field by field? Guess what? For some things, that's even faster. Because think about it. Most of the time when we're asked to analyze something, it's about aggregating things, right? It's about taking massive amounts, usually of numeric data, and aggregating them in some way. It could be by category. We may have it segmented that way, but typically it's you get an average or a standard deviation or a sum or whatever. Okay. But it's some kind of mathematical aggregation of the whole thing. All right. Well, usually I just need 1 or 2 or 3 fields to do that. Okay. Why do I have to bring the entire record in to do that? Okay. And that's what things like in memory did for us. Okay. So that was really cool. And then, of course, there was this whole idea of not all our data is highly structured, you know, that we could even make a relational model or an object model. Sometimes we got to deal with it however it is in whatever format it is, and have some. So then the onus isn't on structure, but on inference, search, query. Okay, it's on how well we do at those things, on things that could be structured in different ways. Okay, and that even includes the things that might be highly structured. Okay, terrific. IT, you did a great job. All right. Guess what? To make this thing truly happen, you also have to have the machine learning, the data sciences, the Internet of Things, the digital thread, all that stuff that really has more to do. And I'm sorry, I said core OE here because it used to be the name of my organization. What that really ought to say is OT, operational technology. Those things that have to do with diagnostics, predictives, prescriptives, artificial intelligence and computational intelligence, all our modeling and analysis, especially OR stuff, IoT, SPC, machine capabilities, statistical analysis. IT groups don't usually do those things, okay? What you need is to have an operational technology group that does those kind of things for you. Guess what? Same problem we had as a lot of our analytic capability. It's spread out all over the place. It isn't highly orchestrated. You don't even know who to go to when you need something like this. All right. Again, one of my big crusades before I go out the door is to really have a good operational technology group together. But what does that mean? Okay. What does IT produce? They produce computational systems. What does a core OT group produce? They produce computational systems. Okay. There's always going to be the same, where should it really happen? Okay. And the thing about this is, it should happen in both of them together. They should be working together. And that's why I think it's so critical that we get our hands around the fact that this is an enterprise thing, and an enterprise architecture function that governs it really ought to include both informational technology and operational technology. Now, please note, I use the phrase informational technology. I didn't say information technology because that usually implies an organization. I'm just saying informational technology and operational technology, which could be looked at as different things from a impact perspective, do need to work together to make a digital transformation for us. So let me get past, I already did that. All right. So what about the analytics? Okay. And again, I think this is one of those things that ISCs really get into. And I know I'm running out of time, so I'm going to speed it up here a little bit. Okay. In fact, I think I could do an entire seminar just on this slide, and you guys would get a lot out of it. And maybe I could do that later on in the year. But this is something that Randy Allenbach and I actually produced, and there's a lot more depth than what you're seeing on the screen. But we were trying to give people the understanding that don't expect somebody who's out there just generating a report of aggregated data to be able to sit there and write a forecasting method for you. Okay, it's a whole different kind of science, really, is what it comes down to. Okay, even though numbers are at the center of the storm on all this stuff, just because you're good at doing math doesn't mean you can do it all. Okay, and of course, as you move up in those levels, the skill base dramatically increases with it. Okay, the other thing about this is when I look at the different kinds of analytics that we could be doing, all right, there's analytics that have to do with the what I would call the asset that you're using to do the analytics, but then there's the method itself. You know, in other words, you know, maybe I'm using to be agile. One of the things one of my goals is to posture my company for a new business in the future. How do I do that? Well, you know, usually it's by extrapolating things I already know. Now, we all know extrapolation only, you know, it becomes less meaningful as you get further away from the full set of data that you have. All right, but you could typically extrapolate so far out and have a reasonable level of confidence that you're going to have an answer that's in the ballpark, right? Okay, well, what do I use to do that? Well, I use optimization methods. You know, I'm going to optimize what I already have, and then say, if I extrapolate that out, to make the thing a little bit more adaptive in nature, how would that upset my optimization? Okay. We know as industrial engineers that optimization is a very fleeting thing. It's also a very costly thing, but sometimes being close to optimal isn't as expensive and it's good enough, and when I'm trying to forecast the future, maybe good enough is enough. I'll never be able to say I'm going to hit every forecast exactly on, but if I'm at least in the ballpark, at least if I've removed a lot of the risk that's associated with it, then I've done a good thing. That's a prescriptive, that's an informatic, that's an operations research machine learning thing that we do. That's built on a foundation of statistics. It's also built on a foundation of augmentation of artificial intelligence. What do I mean by that? I mean that we can actually use analytics to augment artificial intelligence, or vice versa. We use artificial intelligence to augment analytics. And that's really what we tend to do the most. Okay. When do I actually introduce AI as part of my optimization technique? That's an interesting thing. And I think it's one of those things that we're going to see a whole lot of PhD dissertations being written on that in the future, especially as we get better computing methods that will help us to do that, like um, I'm having a mental block, QC. Help me out, KK. Quantum computing. I couldn't remember what the Q stood for a second. Quantum computing. Okay.
But will quantum computing actually speed it? It may speed up to a certain extent, but still.
Right. I
it
don't
does
think,
not change the algorithms.
No. Yeah. Let me step back there. That's what I meant by augmentation. Okay. No, yeah, in a real time sense, I wouldn't want to use it. Okay. But if I have, let's say I'm doing a forecast and I have the ability to do it, I've got some lead time, I could see where, as I do forecasts and I realize that I'm doing a better and better job at it, it helps me understand those critical parameters that basically we are repeatable, and maybe those things at least can be automated for us, um, and by the way, I'm no QC expert here by any measure. I'm learning it myself right now, but just the fact that um, we might be able to analyze what am I trying to say here? More complicated models, and more reaching, maybe reaching is the word I'm looking for. More reaching models that would help us with that. It's been sold to me that one of the really big benefits of QC is the fact that it can help us do things, even though it's on the quantum level of computing, it can help us solve really big problems, and a lot of our really big problems, I think, tend to happen at the level 4, level 5 of this model. So does that make sense? I mean, again, I really shouldn't be trying to expound on this too much because it is not my bailiwick, but does that make sense to you, KK?
Yes,
KK,
yes.
are you there? Okay,
Yes,
good.
yes.
Okay, good. All right. One of the things we've been talking about a lot lately is, the hybrid intelligence aspects of everything. What do we do when we have, where one AI technique doesn't solve the problem, but multiple ones can, and you're like, wow, think about the complex interactions that would have to happen between those techniques, the orchestration of activity that would have to happen. I don't I don't think a serial computer can handle that. You need something that would be a little bit more, even if it isn't truly parallel, at least can emulate parallel in order to make that happen. Knowledge itself tends to be um, a parallel activity, but we tend to force it into a serial paradigm because that's what our computers do basically, and then we just try to emulate what a parallel computation would do. By the way, I don't want to make it sound like that. For those of you who don't know what quantum computing is, it is a computing paradigm that's based on the fact that things aren't just 1 or 0. Okay, it could be somewhere in between. that's breakthrough enough, but it could also do things in you may not look at just one aspect of it at a time. You may look at a lot of them that could be between 0 and 1. So a lot of different kinds of membership. You know, I almost think about it as how we used to talk about fuzzy logic membership. It's along the same line where you can have multiple rules firing at the same time. They each contribute to the outcome, even if they don't contribute anything, you know. But in the end, you know, you get basically this this fusion of knowledge basically that you could point to. So again, I think that's another whole another whole discussion. So I didn't mean to go down that path too much, but machine learning, it's the scientific study of algorithms and statistical models that computer systems use in order to perform specific tasks without explicit instruction. And I think that's ultimately our, you know, again, to me, this is what I'm all about. You know, I want this digital transformation stuff to happen so I could do cool things like this, you know, to make things intelligent, you know, or act intelligently, you know, and to do things like recognizing in patterns and associating patterns with certain outcomes. A lot of you have heard me talk about the feature-rich engineering design. The concept is really simple. Let's mine features off of our engineering design and then relate manufacturing operations to those so that we could automatically generate our manufacturing work instructions. It's not that big a deal. And you know what? We actually did it back in the 80s a little bit, all right? The problem we've always had is getting those features on our engineering design, having them mean something, you know? I can't look at a whole and automatically associate a manufacturing operation. I have to know what kind of hole it is. I need to know what material it's going through. I need to know where it is in the stack up of parts that I might have in the subassembly. All those things come into play for me to determine what the manufacturing operation really ought to be with that. And even with the manufacturing operation, some of it may be repeatable and some of it may be variable based on certain parameters and their values. Okay, so you see where I'm going with all this. To actually produce a knowledge base from all that would take a considerable amount of work. But if we could actually use artificial intelligence to discover that and create our knowledge base for us, oh my gosh, that would be awesome, wouldn't it? To go out and interrogate thousands of models and come up with generalizations that we could use then to associate manufacturing operations. Holy man, I won't retire. It'd be that much fun. So anyway, models derived from mathematical paradigms and sample data make predictions and decisions. I built this slide a long time ago. Believe it or not, of all the slides I've ever produced, this is probably the one that I've gotten the most feedback on from people. Oh man, John, that is cool. I like how you, and it basically is the story of us. This is what we do. You know, I always say, I think one of the huge products that industrial systems engineers produce is enterprise intelligence. And one of the methods that we utilize a lot to do that is machine learning capability. Now, that doesn't necessarily mean that we deployed it. Okay, it just means that we follow these things that would be within this realm of what we would call machine learning. You could take machine learning off of this, which it wasn't on there originally, and it would still apply. This is what we are basically. You know, we are sometimes very system oriented. We are other times very computationally oriented. And depending on whether we are, you know, where we are in the management science, decision science, operations research, and knowledge engineering spectrum, that indicates the kind of analytics that we tend to do too. Okay. And there is overlap too on some of the analytics with diagnostic and prescriptive. And KK, I'm just going to say it out loud. We do a great job on management sciences, teaching them management sciences. We do a great job of teaching them decision sciences. We do a great job teaching them operations research. We need to do a lot better on knowledge engineering. Okay.
Yes.
Yeah. And you and I have had that discussion. I'm saying that out loud because I want them all to hear they need to go back to school and take some knowledge engineering classes if they want to be viable in the future of this. So I'm not saying you guys aren't viable. I'm just saying that it is definitely something you want in your bag of tricks. Okay, so our digital agents, and I already gave you the spiel about enterprise means something other than just a company. I'm going to skip this, but I just want to bring this up really quick and show you that, you know, people are trying to break this down into logical segments. And when they do, they tend to think about it in terms of what the enterprise does, in other words, your business architecture. That's all well and good. There's a lot of things you can relate to those areas. And of course, APQC, they actually put together a process classification framework that's been adopted by a lot of companies, including Spirit, to do things like business writings and things like that. Okay. I personally think we need to focus on value streams rather than areas of business, knowing that different areas of business are going to be involved in each of those value streams. But what are those roles that we need in those value streams, and not cubbyholing them into organizations necessarily, but letting those roles be free flowing, being interdisciplinary if we can. What kind of things do we have in here? And when I look at this, I say, so where are we? Well, we're all over the place. ISEs are in all this stuff. We do everything that's here. Okay. Sometimes we are intimately involved in actually building computational solutions. Other times we're involved in design. Many times we're involved in how they're going to be utilized and utilizing them to actually produce benefit for our companies. I really love this framework. This is an enterprise architecture framework that's emerging called the SAFE framework. And it's what they call a federated enterprise architecture, because it isn't just for IT, it's for an entire enterprise. And Craig Walters has been very vocal about we need to adopt this at Spirit. And I hope we do, at least something like it. Okay. And you can see it even comes into metrics and measures come into play. The analytics process comes into play and all that, but it's considered to be an agile framework. One of the things that we have access to that I have used quite a bit, and I think a lot of you know this, is the IISE body of knowledge, which is both the IE body of knowledge that the Institute put together, and the systems engineering body of knowledge that INCOSE put together. And we merge that together and we have one body of knowledge out of this. Here are all the sections of that. Each one of these sections some of them have lots, and most of them have at least a dozen, if not 2 or 3 dozen areas or capabilities that are part of this. Okay. I built a capability matrix that was based on this. Just to let you know, of all the, I can't remember, in all, I think there's like 190 capabilities. And out of those, only one of them didn't matter. Okay. It had to do with medical management or something like that. Didn't matter to Spirit. I mean, that medical doesn't matter to Spirit. What I'm saying isn't part of our enterprise really per se. So anyway, we use this and those capabilities to go out and do a mapping of what did we think we needed in a digital transformation tool set in order to allow ISCs to do their job, or to embed industrial systems capability into our processes. Okay. It was amazing how well that went. I had a lot of different groups I had to work with on it, and it just went lickety split because everybody could see themselves in it and we're able to say, well, I would need this, or I've already got this. And by the way, we've got this, and it's kind of a standard. We probably wouldn't need this in a product. There was some of that happened. But what we really ended up with, we were able to say, here are the critical things that we think we need in this product going forward. Okay, in these systems going forward, the capabilities that we need going forward, that either we don't have them right now or they need to be a big improvement over what we do have. And then we're also able to say, here's the things that really don't need to be in there. We just need to interface with it because we need data from it, or we need to send data to it, but we already have a method to do it. And a lot of that had to do with like analytic techniques that we use, or things like discrete event simulation. We really aren't looking for a product set that has that, because we already have a standard for doing discrete event simulation, but it does need to map up to it somehow. So integration interface becomes a big deal there. Again, I've said many times that I think ISCs are the enterprise architects of the future, mainly because this whole idea of we need, process technology, information, and application. The technical aspects of that are things that we tend to do or are in our sphere at least. Okay. What I mean by that is, and I think a lot of you have heard me say this, I have I have very little traditional industrial engineering in my background, and yet I have 2 industrial engineering degrees. The things I earned my degrees in were considered fringe when I took those degrees. Now they're pretty much state of the art. There was a time, believe it or not long ago, that operations research was not considered to be part of industrial engineering. And now no one would argue that it belongs there. Okay. There are people that also believe that artificial intelligence is a major part of doing industrial systems engineering. Now I put it in there as computational intelligence and artificial intelligence, to kind of distinguish between the fact that we do have these things that tend to be very heuristic in nature and other things that are discovered through computation. All right. But those two fit with this whole set of stuff that we do. And again, some of these, obviously, we actually have classes of them at the universities. Other ones, not as much, but they're starting to emerge. I'm going to pick on the data science skill set, and I'm not going to go into any great detail on this, but you can look at this, okay? And KK will back me up on this. There was a time when we talked about this skills, the only part of this that we would consider part of an industrial engineering skill set would have been the data analysis and tool expertise. That would have been it, okay? Now this is all ours, all of this, okay? And not the least of which, by the way, when it says graphic design, that means data visualization. That doesn't mean engineering graphic design. All right. That's visualization, what we would do, things with Tableau and things like that. Okay. That's part of that. Okay. But consider that this is all of us now. We do all of these things for our companies. Okay. So what kind of, I use this phrase, enterprise operations. Now I'm going to wrap this up here in the next couple slides here. Enterprise operations analysis teams, what are the things that they will do? Okay. Those of you in my class, I have heard me say several times, there's 2 kinds of industrial engineers now. Those who are learning the old method, and you know what? They will still have jobs for a long time because small companies aren't going to rush to this really quick. They're going to still do things with pocket watches and all that. But the other type of industrial engineer is the one that actually automates things, okay? They're doing the things that are basically going to change the nature of work in the future. Myself, I would rather be that kind of industrial engineer because we know there is probably at least 50 years of activity here before we actually stabilize on any of this stuff, okay? That doesn't mean we won't make progress, and we won't make progress really soon, okay? But look at all the things on that list that you're going to have to be pretty good at in the future in order to be a person that could be an industrial systems engineer. And then the next thing I will ask you is, how many of those things did you actually learn in your undergraduate? And this is where KK, and I give KK a lot of credit. He and Deepak and a few of the others have really done a good job at looking down the road and saying, for digital transformation, what really should we be teaching these people? How do we interject more of what we used to call information technology into our classrooms, and all that? How do we get away from flat spreadsheet analysis to more 3-dimensional analysis in what we do, and how do we make time a major factor in doing all this stuff? I don't think there's a solution yet, but we definitely have an approach, and I think the curriculum will adjust itself around it. So I keep telling everybody, don't think your education's done by a long shot. You've still got a lot to learn. Key takeaways. This is where I'm ending it up. Okay. I hope, after talking for an hour and a half here, that these are the things that you picked up. Okay. That digital transformation efforts are accelerating the need for companies to establish architectures supporting agile product service models and operational technology. Again, operational technology. It's not just informational technology, it's operational technology. We're the guys who do that. There is an urgent need to trim digital waste in the production value stream. You know, if I had it my way, we would put all our resources on just cleaning up our data before we go off and try to do any of this. Okay, that won't happen. So we're going to have to figure out a way to do it on the fly, at least the best we can, knowing that we probably will always have a bit of waste there. But if we can come up, if it at least becomes very obvious that we do, I think that will help. Enterprise architecture can bridge that informational and operational divide in our enterprise through sound engineering practices, systems engineering practices. You know, we call it industrial systems engineering now for a really good reason. And it's not just because we're trying to merge IE and SE. It's because that's really what we do. That's what we produce. Industrial systems, we do industrial systems engineering. We produce industrial systems based on sound and systems engineering practice. And then enterprise architecture can also temper or spur innovation disruption. Okay. Again, I think most of our people who are practicing this, after the architecture itself is fairly stable and we have an infrastructure, most of their job will be doing research and development and actually spurring innovation, disrupting things, and helping us recover from disruption as quick as we can. ISCs will have the tools, the talents, the skills, and demand for the next generation of enterprise architecture. So that's where I'm ending it. And thank you for holding on. Boy, when she said she was giving me an hour and a half, I didn't think I needed, but boy, I sure did, didn't I? Anyway, and I hope it wasn't overboard, guys. I hope you got something out of it. And I know you probably all have to get going, so I won't belabor it. If there is a quick question or two, I'd be more than happy to stay on and answer them. Anybody?
Yeah, John, I got a question.
Yeah, Chris.
Do you know examples, or do you have examples of companies that are starting to do the real-time simulation and modeling to support various decision making that happens?
Yeah, no, you know, in fact, I've been on several ISC calls where people have asked that and it's just silent at the other end. And I've even asked Simeo if they know of anybody, and they said, you know, we are actually starting to build some new functionality into Simeo that will allow us to deliver simulations in the future. But they didn't point me to anybody. You know, my guess is I don't want to say nobody's doing it, Chris. I think it is being done on a small scale right now. I think it's mostly an academic pursuit right now. It's probably one of those things you'll get a lot of dissertations written and theses written on it. But I also think that that is one of those things that probably right now is a real competitive intelligence for.
That's what I was going to say.
You know,
no one's going to tell you they're doing it. And
yeah,
Simeo
right.
can't tell you they're doing it.
Right. I mean, it's like the old days of AI. You know, people are building expert systems all over the place. No one would admit it, you know, because the last thing, you know, it's kind of weird in a way. Some people feel really uneasy when you say that you are supplementing a physical process with something that you built virtually. I don't know why. They just don't trust it like they should. So in a lot of cases, companies that are actually basing their production on it, who do feel good about it, don't want the world to know, not just because it's a competitive advantage, but because they're afraid it'll scare people away from their products. You know, and I just don't understand that myself, you know, but of course we're in this. So it is hard for us to understand how some people think about this stuff, the psychological aspects of it.
I do have a question,
Yeah.
just a little bit, maybe a little bit just more explanation on like, or an example of what knowledge engineering would be, or what that entails.
Knowledge engineering? Okay. Yeah, that's actually a term that popped up in the 80s when people were building knowledge-based systems, okay? And what knowledge engineers were basically, their main task was something called knowledge acquisition, where they would actually sit down with experts and try to mine their heuristics out of them and build decision logic, basically. And most of the time, those decision logics, they called it production rule systems, were basically a decision tree type activity. And then you had an inferencing strategy that could actually move along that tree, looking at sub goals and sub goal that would lead to other sub goals until you got to an overall goal. Okay. In fact, I'll tell you what, Heidi, I did one back in the 80s that I think is a really good demonstration that almost anybody can understand. I may do a brown bag seminar sometime at Spirit and do that for you guys, so you can kind of see what we used to do, and why I think it needs to be done again. Now, since then, knowledge engineering, and even as we moved along in the 90s, it wasn't just about expert systems. It was also about things like fuzzy logic systems, which then again is a kind of a rule, but a different way of representing it, and a very different way of interrogating the rules. Okay, but still, somebody had to create those fuzzy distributions, and that was usually a knowledge engineer. Okay, toward the end of the 90s, it started to include people who did computational intelligence stuff, which was mainly, again, some fuzzy logic stuff, but mainly neural networks were things that knowledge engineers did. Okay, in other words, they were looking for the implicit knowledge that could be gained out of looking at sets of patterns, really, and doing mappings of numbers from one state to numbers in another state. Things like you would typically do in regression modeling. Is another type of neural net that you do. It's called back propagation. There are many different neural net paradigms. I don't want to give you mislead you into thinking that it's similar to, it's always going to be like a regression model. That's just one form of a neural net. But there's neural nets for doing clustering. There's neural nets for doing adaptation. And knowledge engineers back then were the ones who were actually writing those paradigms that we are still using today for neural nets now, the deep learning stuff that we were doing. So, and there's some other things too. There's things like natural language understanding, sensor fusion. There's a thing called rough set theory. Knowledge engineers were basically the guys who practice artificial and computational intelligence. That's what it came down to, all aspects of it.
Okay.
I actually had the title knowledge engineer for a while. It's at Boeing.
Wow.
I always told you guys I've never been an industrial engineer, but believe it or not, at one time I was a knowledge engineer. And you know how it came across on my thing all the time? Knowledgeable engineer. I said, well, at least I'm a knowledgeable engineer. Nobody else is, right? It's like being a civil engineer. Everybody else is uncivil. So. Anything else?
Hey, John, this is Justin Parton.
Yeah,
I got
Justin.
a question for you.
Yeah.
Actually, I got a couple of questions, but maybe
Sure.
we'll only go through one or two.
No, whatever you need.
so
I
in your
can stay on if you can.
Yeah. In your pitch, you had that posted that was talking about innovation outpacing industry's
Right.
ability to adapt.
Right.
So what ways can we get the industry, up to speed or to catch up to these innovations?
Boy, that's
right?
a really good question. Well, I think things like the innovation campus we have at WSU is a start. The fact that academia and industry are now working together, not just to transfer knowledge from one to the other, but actually to produce it and to monetize it. When I mean monetize it, I mean that they're helping us produce things. We could go out to, if we had an area where suddenly we didn't have enough people to produce parts, we could go to WSU and they could produce parts for us, especially things like 3D printed parts where they have the capability, I think that's one way, Justin. The other way is, I think, this is going to be difficult, but we're going to have to do more teaming in industry of the different players in industry to make this happen. Sometimes technology is difficult to put in place because the environments that you're trying to put them in place are not universally built. Okay, so where I'm going with that is, if say I had a brand new way of generating work instructions, okay, and knowing that I could have different manufacturers have with different CAD CAM systems, but if I could at least agree about what the output of those systems are, then I could probably build a system that you could just plug and play. So suddenly that new technology isn't that difficult to implement. It's been especially in the digital world, most of the effort it takes to do a digital integration has very little to do with the product and more to do with the environment that's trying to receive the product. Okay. Now that's talking about innovation where it is actually commercialized. What about innovation where it is really, basic knowledge, research, and all that? Okay. Again, I think the only way that we could do that is by having the universities and industry work very closely together. And it's a two-way street too. It's not just the universities training our people and giving us guidance as to what we need to look out for, but for us giving requirements back to the university about what we think we are going to be in the future and what they need to do to help us out to get there. For years I've been able to be involved with the IABs at Wichita State, both the industrial manufacturing and systems and manufacturing department and the engineering technology department. And the main thing they do every time we have a meeting is they ask us, what do we need to be doing to help you guys out? And every time I go in there, it's me talking for Spirit, but no one at Spirit actually told me what to say, and that worries me sometimes that I'm not really getting very good direction about what we need to be telling the universities what we need to do for us,
Mm-hmm.
So long-winded answer to your question, Justin. Did I really answer what you were hoping I would answer?
Yeah, I definitely think you did. It sounds like we have a lot of silos within industry,
You
right?
bet.
And so that's preventing us from actually moving to our fullest potential, I guess.
Yeah, and you got to ask yourself why that is. Why do we have so many
Mhm.
silos? Is it because we just don't trust each other, or is it because we think everything we do has to be so secretive from each other that we can't possibly work together on stuff? uh I said this week to I said it to you, Justin. One of the things that's been most aggravating in my career is that whenever I see industry come together on something and make some progress and put together what I would consider a really good standard, it's usually good for about 15 minutes before Microsoft comes in and says, we got something better. They weren't part of the consortium. They just watched what the consortium was doing, tried to figure out what they were doing wrong, and then one upped them. And what they did in the end is they made themselves a product out of it. KK, how many spreadsheets do you think have come and gone? I can think of at least 6 other commercial companies that had spreadsheets. How many do the people use now? Excel or things that are variations of Excel. Yeah. Even Google's spreadsheet is really Excel, right? So
Lotus, all those have come and gone.
Lotus, VP, Borland Quattro. Remember that? That was my favorite. I thought that was a terrific spreadsheet, but yet it came and went. And why did it? The funny thing is, all those spreadsheet companies used to work together. Whenever one implemented a functionality, the other one would do it too at the same time. They didn't care. As long as people were using spreadsheets, that's all they cared about. They figured there was enough to go around, Not Microsoft. They went the whole shebang, So, and they went up to everybody. They came up with things that we had never seen before in a spreadsheet, and the other guys knew that they couldn't catch up with them, and they basically put everybody out of business. It's a shame because there are actually things that were in Quattro and Lotus that I really like that don't exist in Excel. I keep wishing it would come back to. Do you know we used to be able to do artificial life in Lotus 1, 2, 3? Can you believe that? Something as difficult as that. We were able to do it in Lotus 1, 2, 3 spreadsheets because it had the ability to change its own macros. It was really weird. It actually could adapt itself to things. So I remember Dr. Homersheim teaching me that, and I thought, wow, I've never seen it again since, not just in spreadsheets, anywhere. So anyway, I'm sorry. I didn't mean to go down a rabbit trail there. Anything else? Justin, do you have another one?
I do.
Okay, go ahead.
I do actually. So we're talking about simulation and digital twinning. Again, on speed, simulation is great and digital twinning is great. I 100% agree with where you're going with it.
Right.
But how do we do it faster?
Oh,
right?
boy.
So
good question.
That's one of the biggest issues that I see is that we want to use it, we want to do it,
Right.
But it's gonna take me 6 weeks or 6 months to be able to set it up, and by that time the decision's already made and we're already moving forward. So how do we speed that up?
Awesome question, because I'll tell you the truth. I think that's the holy grail on digital twinning. How do we make things more real time? Just like and even how do we deploy it in a way that it can be utilized in real time? I've actually said that about when digital twinning first came up. I looked at it and I thought, well, we're already doing that. We're doing, we do finite element analysis. We do acoustical and aerodynamic analysis. We do discrete event simulation. It's a virtualization of what we're doing, and we just do it off on the side here in the hopes that somebody will take what we got and use it as part of the design rather than just to validate decisions that have already been made, right? And so that by the way, that's the cultural part that we have to fix to make this happen. Okay. But what happens when you try to truly automate that? Part of digital twinning too is control. Okay. The idea that I could be half the world away and understand my manufacturing operations from just looking at a control board on my screen. And by the way, I might be able to even change them from that control board on the screen. But I've got the tools in place, those twins in place that will allow me to understand really quick what it is we need to do, And oh, by the way, when I get really good when I can really start to trust them, shoot, I won't even need to know that you're doing it. Just do it. I'm happy. I know you can do the thing. All right. But then obviously time is the factor then, how do we make it more real time? All right.
I think Dr. KK has a comment or.
Yeah, go ahead, KK.
Yeah, I think doing that also requires you to have IoT-based devices that can provide real-time feedback back to the digital twin, not to the real one.
Yep. And in fact, I was going to just say that next, this is one I personally think the reason it has, because like I said, this is not new, any of it. The concepts were there a long time ago. Some of the technology has actually been there for decades, okay? But not all of it was there, okay? And I think that's got a lot to do with the fact that computing itself has sped up is allowing us to do some of these things now that we weren't able to do before. Like KK just said, it wasn't very long ago that most of your electronic communication protocols, there was a lot of overhead in them. First off, there was translation that was needed. There was building the communication paths themselves. Even when they were wired, they could be slow when you had too much traffic on them. And then when you tried to do it wireless, oh my gosh, then you also had, especially when you went to the wireless paradigm, you had to be careful about protecting things. So you had to encrypt things, decrypt things. Now, yeah, I understand that those things may only take milliseconds, but add them all up and suddenly there's a delay, and it's a noticeable delay, a delay enough that you wouldn't want to. I think about that. I was thinking about our chem lines, we've been trying to automate our chem lines for years, and the things that have always held us up is the fact that we can't respond quick enough to anomalies before to the point where the bad thing happens. We may realize it's there, but it's already happened. Okay. It's the same. I'm doing, I told you about this robotics thing I've got going on right now. The thing I was on for the ARM was path management. Okay. It's not just the path of the robot, but it could be the path of like a cutter or something like that. Okay. Well, let's say I'm cutting a part. Okay. By the time things go bad, it's already a bad part. Okay. By the time I even get an indication where I might be able to even bring things back into tolerance. Okay. By the time I can respond to it, it's already whacked up. Okay. I got to get rid of it. No, I'm scrapping that part. How do we really make that real time? Okay. So KK's right. Okay. Communication protocols, faster communication protocols are definitely go and help us with this. Okay. But there's another thing I think could help, and that is put it closer to where it's happening. All right. In other words, say I've got that cutter. It's going along its path. It's starting to get off. Don't send a signal halfway around the world to John to let him know it's off. And by the time John responds to it, it's already bad. Have something right there at the edge where the machine itself, this is part of the machine learning, can correct itself. Okay. It still won't be truly real time, but it'll be pretty darn close, probably close enough for most of the things that we do. Okay. Now I know that doesn't help with discrete event simulation. Okay. One of the things we've talked about with twinning, with discrete process twinning, where you might have a model, is having the model be able to get parametric data directly from the physical process to go out and run. Okay. Now, what does that mean? Well, you can't run it in real time. Okay. You got to actually run ahead of time. Okay. The only reason why you'd want to do that is to forecast what could possibly happen based off how the thing is operating right now. And to do that, that means you have to actually simulate faster than real time, in order to know that before it actually gets there. If you do it in true real time, you're just mimicking. It's just a visualization of what's happening down there, basically. Okay. But if you could actually speed up the simulation to say, I got this stream of parameters based off that stream, I've projected out for the next 6 hours. And oh boy, you're going to have a problem here. Let's get a correction going here. Okay. Then, but that also means that we have to have that communication channel. That means that data coming from the physical source is being communicated into the simulation model, is being received at the same time while other things are coming in after it, So now we get into this is one where I think QC could help us. Not only is it a parallel activity, but it's a time sensitive parallel activity. You can't do that with serial computers. I'm sorry, unless it is an extremely simple model, you just can't do it. At least not on the scale that industry needs. Okay. So the short answer to this long explanation is technology needed to catch up with us, and it still needs to catch up with us. Okay. And it will. There are things coming up that will do this. By the way, one thing I didn't say anything about at all was blockchain in all this. It has a role, those build records that we do, they could be managed through a blockchain. Okay. And that means that could speed up some data transactions for us if we do it right. It could definitely secure those transactions better. So anyway, I just want to do that while I was thinking about it. Anything, KK, anything else?
Yeah. So to your point, we have been using all the information that you've been providing us. So we have changed our curriculum quite a bit. And we are continuing to do that. And part of that is actually, trying to put IoT-based sensors on the lathes and the milling machines to figure out how to connect them to real-time digital simulation. So that's what we are currently moving towards, teaching students how to do real-time digital simulation.
And that's interesting too, because there's different strategies for that. In some cases you can have a direct connection. In other cases, another way that could speed things up a little bit would be to fuse your data, before you actually send it to the model. In other words, come up with something that's a good representation of a single data point that's a representation of 6 or 7 data points. Send that one, because now it only has one thing to interpret, but that means you've done a good job of clustering that data, that you could do those kind of associations. Yeah, I mean, it's amazing. There's a wealth of opportunity. By the way, those of you who've been thinking about masters and PhDs, we're talking about things that could be dissertation level activities to go out and explore. Anything else? KK, did you want to say anything else about the curriculum?
Oh, I'd like to have these slides, because this is what I use to tell my faculty what to change. So.
Sure. You bet. Yeah, my pleasure. My pleasure. I'll give you these. Absolutely. Yeah. I had a few backup slides, but I realized before I got on it, some of them have spirit stuff in it, so I'm going to take those out. But but the rest of you, you're more than welcome to have.
Yeah. Thank you.
Okay, sure thing. Anybody else? And guys who stuck around, thank you so much. I appreciate it. I know this was long-winded, but obviously it's a big picture thing, and to give you a full appreciation for it all, we had to go through a lot of stuff. Hopefully maybe we could, even in this, I didn't go to a lot of depth. If there's anything in here that you'd like to have more depth on, like the analytics stuff, I'd be more than happy to do follow-ups on this. Okay. And make them shorter. Okay. So, all right. Otherwise, Thank you very much, Heidi.
Yeah, thank you.
Anything
Thank you,
else
John.
yeah, and be watching. We've got some upcoming events, not necessarily webinars, but other events that the chapter's going to sponsor. Please, guys, participate. That helps us more than anything else. So.
Yeah, thank you, Dr. Huffman. I know you wanted me to mention a couple of things, and we're still working on an August event. We want to do something in the baseball stadium, the new one.
Yeah.
And so we're still working on that and finalizing the details. So sorry, I don't have a lot of information on that one, but I know we're looking at in September doing an all Kansas event. I think at Emporia, possibly.
Yep. Yeah, that's, and I haven't heard from Ian yet, but he's working that for us. Okay, he'll let us know what he's lined up here in the next week. He told me.
Yeah, and we're also trying to maybe get a mixer with the student chapter, and at the end of September as well. So
yeah, that'd be fun.
The big ones coming up.
Yeah.
So look for that.
And guys, by the way, I should jump in here and say if you got ideas for anything that you'd like to see the chapter do, contact Heidi. Okay, she's doing an outstanding job of coordinating this stuff and getting a really good agenda stuff together. You know, we've had events that we do regularly every year, and they're good events. You know, I hope we continue to do it, but that doesn't mean we're limited to those. We could open it up to anything that you would find appealing, you know, at least if we could do it and if we can afford it. Okay, so anyway,
yeah.
All right. Well, thank you all very much. And
thank you so much, everyone.
Yeah, and if you have any follow-up questions, just feel free to send me an email. Okay.
All right. Thanks, everyone.
Have
a good rest of your night.
Yeah. Bye.
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 Thank you.